All right, for our next section, we're going to talk about adding integers. And to kind of start this idea of adding integers, we're going to look at adding on a number line. I do want to be very clear. If you like this idea of adding on a number line, don't get super, super attached to it because most of the stuff we're going to be adding is going to be kind of too big to make using a number line useful. This is more just a way to get you to understand kind of what's happening conceptually, okay? So first video, we're going to look at adding integers on a number line. And then after this, the second two videos for this worksheet, we're going to look at just adding numbers and then looking at some like applications of adding integers, okay? So a couple of things that you need to understand. When you're adding positive versus negative numbers, it impacts a number line differently depending on if your number is positive or if your number is negative. So if you are adding a positive number, that would indicate that you need to move to the right. So you would start with your first number, you kind of plot it on the number line, and then you would move to the right according to the second number. Now, if the second number that you're adding is negative, that would tell you to move to the left. And that should kind of make sense. Moving to the left makes us smaller, moving to the right makes us bigger. Negatives are smaller than positives. Like there are things about this that should kind of conceptually make sense. Now, if you have a sum or difference where you're combining positives and negatives, you can always think of the absolute value of the larger number. So you can look at the two numbers, whether both positive or both negative, it doesn't matter. But generally, you think of it like this when you're adding different signs, so one positive, one negative. And you look at the absolute value of the two numbers, and whichever number has the larger absolute value kind of tells me which direction you ultimately need to go. Okay. Now we're only going to do two really, really basic examples of this, and then we're going to look at more like defined rules for adding integers. Okay, so let's go ahead and start. So example one says add each pair of integers using a number line. Okay, so for part A, we have -9 plus 5. Now, just the most generic way we could approach this is we would start by plotting or just gently making note of where -9 is on a number line. So -9 is right here. Now, from -9, we want to add +5. That +5 tells me I want to move in the right-hand direction. So from -9, I would move 1, 2, 3, 4, 5 units to the right, which puts me at -4. So that tells me if I have -9 and I add +5, my sum is going to be -4. And think about this. This kind of makes sense. So let's say that you are dealing with temperature. You wake up one morning, the temperature is -9 degrees. By lunchtime, the temperature has increased by 5 degrees. What's the temperature outside? Well, it would be -4 degrees. Okay. So try to find something in the real world that kind of makes sense. Sometimes money works for people. So let's say your bank account is at -$9, you deposit $5, your bank account is at -4. So find something that kind of just logically makes sense for you. Okay. Now you could approach this a little bit differently. What if instead of starting with the -9, we started with the 5. Okay, we already know that addition is what's called commutative. Remember that from the previous chapter. The commutative property tells us that it doesn't matter the order we add in. The sum is going to be the same. So let's say instead of starting at -9, we started at +5. Now, if we started at +5, we would be adding -9. And adding a negative is kind of going to have a negative impact. That sort of makes sense. It's going to make something smaller. So you would move to the left-hand side, right? So instead of going to the right 5, I'm going to go to the left 9. So I would go back 1, 2, 3, 4, 5, 6, 7, 8, and 9. So either way you slice it, whether you start with -9 and add +5 by moving to the right, or if you start with you start with +5 and add -9 by moving to the left, either way, you're going to get a sum of -4. Okay? Now for part B, we're adding two numbers that have the same sign. They're both negative. Okay? So it doesn't matter which one you start with. Let's just take this one very literally. We're going to start with -4. Now I'm adding -3. So kind of think about this. So let's say that your bank account has -$4 in it, and you add $3 more of debt. Okay, so think of that -3 as like debt. If you add $3 more of debt, that puts you at -$7. You could also think of it as, let's say you're on a top floor of a building and you go down 4 stories, and then you go down 3 more stories. How many stories have you gone down? Okay. You could think of it as like diving. Okay, you're at the surface of the water, you dive down 4 feet, you dive down an additional 3 feet. Diving down would be a negative, so that puts you 7 feet below the surface of the water. So there are several different ways you could think about this, but if you're looking at just exclusively a number line, you plot one of the numbers on the number line and then apply the second number. So we've plotted -4. We want to add -3. That negative tells me to move to the left. So I want to move to the left 1, 2, 3 times, which puts me at -7. Okay? Now, just for fun, let's say that we had -3 plus -4. So let's say we applied that commutative property and we changed the order of these numbers. Let's see what that would look like. So if we did change the order of these numbers, we would be starting with -3, and we would want to move to the left 4 units. So 1, 2, 3, 4. Either way you slice it, we get -7 as our sum. Okay, so that's just a really, really basic understanding using a number line of what's going on. You can use a lot of things. Money works for a lot of students. Temperature works for a lot of students. So find something in the real world that can kind of help you work through some of these different scenarios with adding integers.